Hi everyone, in this video we are going to discuss Lewis structures. So Lewis structures are basically just a visual representation of a chemical formula. So let's start off by looking at the diatomic molecule bromine, so Br2. So in order to draw this out, the first thing we need to do is identify the atoms or the elements. And so we just have two bromine atoms. So you draw them out separately. The next thing you do is you identify the number of valence electrons. So we would find bromine on the periodic table and we would see that it is in group 7 or it is a halogen. So that means it has 7 valence electrons. So then you just draw the valence electrons on. 1, 2, remember the first two go together. Then 3, 4, 5, 6, and 7. Okay? We'll do the same thing over here. 1, 2, but the first two together. 3, 4, 5, 6, and 7. And so what we see here is that each of these bromine atoms have 3 lone pairs. So 1, 2, and 3. But they each have a single electron that is left unpaired, or an unpaired electron. And so what we do with Lewis structures is we find a way to take unpaired electrons on different atoms and we bring them together to form a bond. So essentially what we do, let me get rid of this arrow to make it a little bit easier to see. Essentially what you do is you just draw a line from this one electron all the way over here to the one that's by itself. Because remember, this is a lone pair, this is a lone pair, and this is a lone pair. So what we do with a Lewis structure is we just try to show how these things are coming together. So is it one unpaired electron and another one? And we'll do some other examples where it's more than 2 electrons in just a little bit. So after I do this, because that's hideous, right? That's very difficult to see. So you redraw it. So you have bromine. Anytime you have a bond, right? That's what that line is. Anytime you have a bond, you just draw a straight line. And then you write the other atom. And so what we do next is you must fill in your valence electrons. You have to do that. And so we know we have 7 on each one, but we do 3 lone pairs because of the 1, 2, 3. So we write them in 1, 2, 3, 4, 5, and 6. We're just redrawing 1, 2, 3, 4, 5, 6. And so this would be considered maybe your pretty picture or your redrawn picture. And so what we can do here is look at that bond and put a name to it. That is considered a single covalent bond. So single, that means they're sharing 2 electrons. Covalent, that means they're sharing. And then a bond just means you're bringing 2 elements together and they're having some kind of electron exchange. So this is considered a single covalent bond. But the thing is, after you draw your Lewis structure, how do you know what you've done is correct? How do you check yourself? And then what we do, at least in this course, is we use what's called the Octet Rule. And so the Octet Rule simply says that most elements, so I'm just going to say atoms in general, we're going to be very vague here, typically want 8 electrons, okay, in their outer shell. So in other words, they want to have 8 valence electrons. So every time you draw a Lewis structure, you must go back and check to make sure that you have obeyed the Octet Rule. So let's look back at this structure right here. So we're saying each one wants 8 electrons. So we're going to start with the bromine on the right and we're going to count. So this is 1, 2, 3, 4, 5, 6, and then a bond has 2, so you have 7 and 8. So this bromine occupies the Octet Rule, or it obeys the Octet Rule. So that's really good. So now we have to check the other one. 1, 2, 3, 4, 5, 6, 7, and 8. So this bromine also obeys the Octet Rule. So we have a good structure. We have a beautiful Lewis structure that has a single covalent bond. So now let's kind of ramp it up a notch. So what I'm going to do is show you kind of an exception. Hydrogen and helium. If you recall, these are the elements that have just that innermost electron shell, and what we know about that shell is that it will only allow 2 electrons. So whenever we're doing hydrogen and helium, we must remember that they really want 2 electrons, not 8. Everybody else wants 8 valence electrons, but hydrogen and helium only want 2. So now that we know that, let's do another example. Let's say we wanted to write out the structure for HF. So the first thing we do is we separate out into our different elements. And so we have hydrogen here and we have fluorine here. We look at the periodic table and we find out that hydrogen is in group 1. It's an alkali metal, and so it only has 1 valence electron. Then we find fluorine. Fluorine is in group 7. It's a halogen, so it has 7 valence electrons. So we go 1, 2, then fill accordingly. 3, 4, 5, 6, and 7. Okay? Now all you do is you circle your lone pairs, so identify your lone pairs, and then identify your unpaired electron. Eventually you'll get to a point where you don't have to circle your lone pairs, and that's totally fine with me, but while you're learning, it's just good practice to kind of make sure you get rid of them and there's no way you're using them to do bonding. So right now, we can see that we have one unpaired electron on hydrogen, one unpaired electron on fluorine, and all we're going to do is just draw a line, so just connect the dots. And so again, always redraw. Never submit something like that to me. That's ugly. I would cry myself to sleep. Please don't do that. What you do is you write your hydrogen, redraw your line, write your fluorine, and then just fill in your lone pair. So we had the 1, 2, 3, 4, 5, and 6. Now you must check that octet rule. So we'll start with fluorine. 1, 2, 3, 4, 5, 6, 7, and 8. So fluorine is good. It obeys the octet rule. Now remember, hydrogen just wants 2. So let's count. 1 and 2. So hydrogen obeys its version of the octet rule, which is just 2. The 2 rule? I don't know. There's no name for it, but it obeys its version of the octet rule. So now what I want to do is take it up even a step further and ramp it up a notch. And so let's look at oxygen. So oxygen has 2 oxygen atoms, right? It's a diatomic molecule. If we find oxygen, it's in group 6, so it has 6 valence electrons. So let's draw this out. 1, 2, 3, 4, 5, and then just pick one to double up. 6. Same thing here. 1, 2, 3, 4, 5, and 6. So we double up. Now all we do is connect unpaired electrons. So I'm just going to go from this one straight across here, and then from this one at the bottom straight across here. So what we've done now is created 2 bonds. There's one bond, and here's another bond. So again, redraw it. We want to make sure that this is pretty, and that is just terrible. So here's oxygen, double bond, another oxygen, redraw in your lone pairs. Again, it doesn't matter where you put them, just make sure that those electrons stay together if they're within a lone pair. So what we want to do now is check that octet rule for each one. So 1, 2, 3, 4. Now each bond has 2. So 5, 6, 7, 8. So this oxygen is good. Now we do the same thing over here. 1, 2, 3, 4, 5, 6, 7, and 8. Good. So this oxygen obeys the octet rule as well. So now this would be considered a double covalent bond. Okay? So this one has a total of 4 shared electrons. So now I want to challenge you, and I want to see if you can draw out nitrogen. So nitrogen is also a diatomic, and so here is my question for you. What type of bond does nitrogen have? All right, did you get an answer? If not, that's totally okay. We're going to work through it together. So the first thing you do is identify your atoms. So we had 2 nitrogen atoms. We know they're in group 5 if you found it on the periodic table, so it has 5 valence electrons. So the first 2 go together, 1, 2, and then 3, 4, and 5. Same thing over here, 1, 2, 3, 4, and 5. Now, excluding your lone pairs, draw connections here to connect the dots. So we've got 1, we've got 2, and then on this one, you kind of have to make a goofy looking smile in order to do that. So you go from one side to the other, and you have your third bond. So again, always redraw. So nitrogen, 1, 2, and 3. Another nitrogen, put your lone pair wherever you think it makes it look the prettiest, and come up with a perfect answer. So hopefully you said that nitrogen has a triple bond, which is absolutely correct. Now remember, a triple bond is sharing 6 electrons. Okay, so we must keep that straight in our head. Now I want to try another one. Let me try water. Okay. Question is, how many double bonds are in water? Okay, go. Good luck. All right, did you get an answer? Hopefully you did, but if you weren't able to actually come up with an answer here, that's totally okay. Don't fret. We're going to go through it together. So here's my first hint. If you don't know what to do, try to make your molecules symmetrical. Okay, look at nature. They give you 2 eyes. They're on opposite side of your head. We have 2 arms. We have 2 legs, so on and so forth. Nature likes symmetry. So if you have 3 atoms like this, make them symmetrical. I'm sticking oxygen in the center, and then the hydrogen's on the outside. Once you've done this, go ahead and start filling in your valence electrons. So hydrogen's in group 1, it's an alkali metal, so that just has 1 valence electron, so 1 on each of these. Then now with oxygen, oxygen's in group 6, so it has 6 valence electrons. So again, 1, 2, 3, 4, 5, and 6, that's fine. And then we just connect dots. So we have 1 here to here, 1 here to here, and we've made 2 single covalent bonds. So the answer to this question, how many double bonds does it have, is 0. There are no double bonds in this molecule, but there are 2 single bonds. Hopefully that makes sense. We need to make sure we keep this clear in our head. 2 single bonds does not equal a double bond, okay? All right, next question. Now we're moving on to CH4, or methane. We're going to talk about methane in a little bit here. Methane. How many single bonds are in methane? That's my question. Go. All right, did we come up with an answer? Hopefully we did, but again, if you aren't there yet, don't worry. So, nature likes symmetry. We have 5 atoms here, stick carbon in the center, put hydrogen all the way around it, make it symmetrical. Okay? Then you fill in your valence electrons. Hydrogen's in group 1, it only has 1 electron. Then we look at carbon. Carbon's in group 4, it has 4 electrons. So now, this one's kind of tricky because you want to put the 4 like this and then go here and here. But if you start connecting the dots, this would work and this would work. But now what do? There's no way to connect this one to a lone pair. So your central atom, so in this case, which is carbon, your central atom, come on. Your central atom sometimes will split up its lone pairs. And so we'll put one here, and we just connect the dots. The important thing is, if I tell you that this definitely has 1 carbon bonded to 4 hydrogens, this is the only way you could do it. You would not be able to bind it to hydrogen without splitting up that lone pair. So you need to do a ton of these. Practice every single molecule you can get your hands on until you start to feel comfortable with it and notice the trends. So now, we must redraw this because that is hideous again. So we have carbon to a hydrogen, carbon to a hydrogen, to a hydrogen, and to a hydrogen. Although that's not much prettier, is it? Oh well. In theory, it's much prettier. So the question was how many single bonds? There are definitely 4 single bonds in methane. There's 1, here's 2, here's 3, and there's 4. Hopefully that makes sense. Take care of yourself. Have a good week, guys.